So now we're going to talk a little bit about the unit circle. So a unit circle is a circle on the coordinate plane with a radius of 1. So if I just sketch a coordinate plane and then sketch a circle, we know it's not perfect, but it's sketched, of course. And again, we know that the radius of this circle is 1. So we want to focus on some ordered pairs right now. And we're also going to use our knowledge of special right triangles. So there are 3 ordered pairs in each quadrant that we are interested in. One about right here, well, as well as probably the ones on the axes. So we'll go ahead and say those as well. Those should be pretty obvious, right? So the very first one over here is 1, 0. The one up here, 0, 1. The one on the left, let's try that again, is negative 1, 0. And then the one at the bottom, 0, negative 1. But the other 3 that we're interested in are, you see the first one, second one about right here, and then the third one about right here. You can see that they're not really evenly dispersed throughout. And it's because the first one is at a 30-degree angle from the center and from 1, 0. This is where we start on our circle. And then we go clockwise or counterclockwise. Clockwise would be a negative angle. So positive angles are in a counterclockwise direction. So this point is at 30 degrees from the center. This one is about, I meant to put it at 45 degrees. And then the third one is at 60 degrees. These are the ones we're going to be interested in. And really all the way around. So this one would be at 45 and then 60 and 30. And then here's about 45. Well, in addition to the 90 degrees and the 180 degrees. So these would be, this one would be 30 plus 90, 45 added to 90, and 60 added to 90. Or really we can think about it from right here. And actually that's what we're going to do later on. And really I'm going to focus on the first quadrant, because once you learn the first quadrant, you can apply what you've learned to the first quadrant, to the second, third, and fourth quadrants. And maybe we write that down just as a reminder. First quadrant, and we use Roman numerals to indicate second quadrant, the quadrants, third quadrant, and fourth quadrant. So there was my 45, and then the 30 and the 60, 45, and these 2. So again, what I'm going to be telling you and teaching you about is we're going to be focusing in the first quadrant, and then from there, you can apply that to the rest of it. So let's see if we can increase so we can focus on it. Nice. All right, so what is the ordered pair of each one of these 3 in quadrant 1? Well, like I said, this point is at a 30-degree angle. So if we remember what we talked about with the 30-degree angle, or 30, 60, 90, well, we drop this altitude, and that makes it a right angle. Of course, the smallest one is going to be our 30-degree angle, and the large one our 60-degree angle. And what we learned about 30, 60, 90 triangles is that the hypotenuse is twice the length of the short leg, and then we multiply the short leg by square root of 3 to get the long leg. And do you notice that the ordered pair, that the short leg is going to be the y value, and that the long leg in this case is going to be the x value. So my x value, well, let's get to the x value here in a minute. The y value is 0.5. Now, how do we know that it's 0.5? Well, remember that this is the unit circle, that this radius is 1. Well, this is still a radius. So the hypotenuse is always going to be 1 of any of these right triangles that we're going to be talking about. So I take half of the right triangle, and that is the short leg, which is 0.5. And now I multiply that by root 3. Now, I did say 0.5, right? Let's really use fractions instead. So now, what is 1/2 times the square root of 3? Well, you could think of it as 1/2 times square root of 3 over 1, And so what we end up with is the square root of 3 halves. So right now, that may not make a lot of sense to you as far as decimals, because decimals make a lot more sense to us, right? But you could plug that into your calculator and find out what that decimal is. For now, let's go ahead and look at our next one. So our next one is now this whole thing right here is a 45-degree angle. So if I drop the altitude, this is a right angle, and now my x is going to be equal to my y. And again, my hypotenuse is 1, and so now I know that if I had these two sides, I would multiply it by the square root of 2 to get the hypotenuse. So now I need to divide it by the square root of 2 to get my two sides. Well, I'm not allowed to leave it in the denominator. So I'm going to write it off here to the side that this would be 1 divided by the square root of 2. Now, do you remember last time how we rationalized the denominator by multiplying by root 2 over root 2? So this equals root 2 over 4, root 4, which is 2. So both are going to be the square root of 2 over 2. Now sometimes students want to simplify that because they see the 2's. Well, remember, the square root of 2 is really 1.41 blah blah blah. And 1.41 blah 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 divided by 2 is not reducible, right? So this is some irrational fraction, which is an oxymoron, but it's an irrational number. It's an irrational number divided by 2. All right, the next one is a 30, 60, 90 again, but now this full angle is 60 degrees. And now up here is the 30. So now our x value is going to be half of the hypotenuse. And the hypotenuse is 1, so this is 1/2. And the y value is now the long leg, and so it's 1/2 times the square root of 3, or root 3 halves. Now, as you work your way around the rest of the circle, just realize that these are still x and y coordinates, right? So on the left, in quadrant 2, the x coordinate is going to be negative, but the y coordinate is going to be positive. In the third quadrant, down here, they're both going to be negative, right? And then down here, the x will be positive, the y will be negative. So what's the point of all this? Well, the point of all this is to help us with trigonometry and calculus, the trigonometry and calculus. We're sometimes going to want to know sine, cosine, and tangent. So I'm going to give you a quick introduction to sine, cosine, and tangent. So sine, cosine, and tangent. Now these are all ratios. Just like pi. Pi is a ratio. It is the ratio of the circumference to the diameter. Well, these, the sine of an angle, the cosine of an angle, these are all talking about angles, are going to be certain parts of that right triangle. And sine is going to be the ratio of the opposite side to the hypotenuse. Now you might be asking, why am I learning this? Honestly, right now, you're not ready to know. Really, I'm teaching you this it's like push-ups. It's going to be a strategy you're going to use later on. I'm just giving it to you now so that when you get it later, you go, hey, I kind of remember this. The cosine is going to be the adjacent side. I'll give you an example here in a minute. And the length of the adjacent side of the triangle over the hypotenuse. And the tangent of an angle is going to be the ratio of the length of the opposite side to the adjacent side. Now, taking the first letter of each of these, S for sine, O, and H, C, A, and H, T, O, and A. This is what people will refer to as Sohcahtoa. Sohcahtoa. And it sounds like an old American Indian word or something, but it helps you remember that sine equals the opposite over hypotenuse, cosine equals the adjacent over hypotenuse, and tangent equals the opposite over adjacent. I also remember a guy trying to teach me much later on. I had memorized it, Sohcahtoa. Some old hippie comes around here teaching old algebra. So if that helps you, remember it that way, or come up with your own way of remembering it. Again, this is for trigonometry much later on, but memorize it however you can. So now, knowing this, I can go back over to my unit circle, and we can ask, what is the sine, now we only use the first three letters, of 30 degrees? And the sine of 30 degrees we know is going to be the opposite over the hypotenuse. Well, the opposite of 30 degrees is the y value. So 1/2. It's this length right here, which is the height, which is 1/2, over the hypotenuse, which is 1. So 1/2 over 1 equals 1/2, which is 0.5. So we know the ratio of the sides for 30 degrees is going to be 0.5. And usually sine, cosine, and tangent are measured to 4 decimal places, so probably 0.5000. We can find the cosine of 30 degrees, which is now the adjacent. And the adjacent side of 30 degrees is down here, which is this length of the triangle over the hypotenuse, which is actually the x-axis. So it's root 3/2 over 1. And root 3/2 over 1 is going to be root 3/2. And it would be whatever that decimal is to 4 places. And then the tangent of 30 degrees, meaning the ratio of the sides of the triangle at 30 degrees of this angle, is going to be the opposite, which, again, the opposite of 30 degrees is the height of the triangle, which is 1/2, over the adjacent, which is root 3/2. So this one is a little more complicated because now we're dividing fractions. This is called a complex ratio. So this is 1/2 over root 3/2. And the way that we simplify that, of course, that fraction really is 1/2 divided by root 3/2. So we turn division into multiplication, 1/2 times 2 over root 3. We can see that these two are going to cancel, and I get 1 over root 3. And then I have to multiply by root 3 over root 3 to rationalize the denominator. And the tangent of 30 degrees is going to equal root 3/3. And if we want that decimal, of course, we divide root 3 by 3 and round it to 4 decimal places. And remember that we cannot simplify that, even though we see the 3's. You might want to, but this value is really 1.732 ... It goes on forever. So 1.732 divided by 3 is not anything reducible. This is in reduced form. If we had left it like this, that's not in proper reduced form. But really for now, I just want you to focus on coming up with the ordered pairs, depending on 30 degrees, 45 degrees, 60 degrees, and then in the other 3 quadrants. And I just wanted to introduce you to Sohcahtoa, sine, cosine, and tangent. But make sure that you can find the ordered pairs for now.